ভেরি গুড ইভিনিং। আজকে আমরা যে চ্যাপ্টারটা পড়ব দ্যাট ইজ ইলেকট্রোলিসিস। নাও হোয়াট ইজ বেসিক্যালি ইলেকট্রোলিসিস? Electrolysis is a process, it is a process of decomposition of a chemical compound in aqueous solution or in molten state accompanied by a chemical change by using direct electric current. This is basically the definition of electrolysis. Now, first of all, we should know what actually electrolysis is. Now, electrolysis, now the word itself is saying there are two. One part is electro and the second part is lysis, Lysis. So what is the meaning of the term electro? Electro means flow of electron. Flow of electron. So that is the basic meaning of electro. Electro means flow of electron, or we can say the flow of electricity. Okay. And what is lysis? Lysis is separating. Lysis is separating. Separating. So what is basically electrolysis? It is basically bringing a change. What is the change? It should be a chemical change. So specifically it is bringing a chemical change in a substance by the passage of electricity. Okay. তাহলে একটু ইলেকট্রোলিসিস প্রসেসটা একটু বাংলায় বলি। ইলেকট্রোলিসিসটা কি? এটা হচ্ছে গিয়ে বেসিক্যালি আমরা একটা কেমিক্যাল কম্পাউন্ড নিচ্ছি, ঠিক আছে? ফর এক্সাম্পল সে H2O একটা কেমিক্যাল কম্পাউন্ড, কিংবা ধরো নিলাম H2SO4, এটাও একটা কেমিক্যাল কম্পাউন্ড, কিংবা নিতে পারি HCl, এটাও একটা কেমিক্যাল কম্পাউন্ড। তা কোনো একটা কেমিক্যাল কম্পাউন্ড আমি কি করব, সেই কেমিক্যাল কম্পাউন্ডটা থাকতে হবে আইদার মোল্টেন স্টেটে কিংবা অ্যাকুয়াস সলিউশন। অ্যাকুয়াস সলিউশন মানে হচ্ছে গিয়ে বেসিক্যালি মিক্সড উইথ ওয়াটার। এবার তার মধ্যে যদি আমি ইলেকট্রিসিটি পাস করি তাহলে কি হবে, আমি ডিকম্পোজিশন হবে। কার ডিকম্পোজিশন হবে? ইফ আই টেক H2O, তাহলে H2O ডিকম্পোজিশন হবে। দ্যাট মিনস দ্য মলিকিউল অফ H2O সেটা ডিকম্পোজ করবে। ডিকম্পোজ করে কি তৈরি করবে? আয়ন ফর্ম করবে। তার মানে বেসিক্যালি হোয়াট আই এম গেটিং ইজ দ্যাট যে কোনো একটা পার্টিকুলার কম্পাউন্ড থেকে ইফ আই পাস ইলেকট্রিসিটি, so when I am passing electricity through a particular compound, and that particular compound should be in a molten state or in a aqueous solution form. Okay, so from the compound we will get ions. Got it? Now the first question immediately that will arise is, what are basically ions? Ion kake bole? Ions hocche giye, what are ions basically? Ions are basically charged atom. Now if I take any element, for example if I take sodium. Now what is the atomic number of sodium? The atomic number of sodium is 11. What is the electronic configuration of sodium? That is 281. Got it? So if I take out one electron from sodium, so from sodium, now this is sodium, this is a atom. Now if I take out one electron, so I will get Na plus. Now this is the ion, this is the atom. Similarly if I take chlorine, atomic number is 17, electronic configuration is 287. So if I add one electron, so I will get Cl minus. So this Cl minus is also an ion, and this Cl is the atom. So what are basically ions? Ions are charged atom. They can be charged with positive electricity, they can be charged with negative electricity. Now this is known as a now the name of this one is cation. Na plus is basically cation. And what is Cl minus? Cl minus is basically anion. So positively charged ion are known as cation, negatively charged ion are known as anion. Got it? So what we are doing basically in electrolysis, now we are getting back to electrolysis. Now we are passing electricity through a particular chemical compound. That chemical compound should be in an aqueous state or in a molten state, and what we are basically getting from that particular chemical compound, now that chemical compound is dissociating into ions. Now if I give you one example, for example, if I take acidified water. Now why I am taking acidified water, the reason is very simple, because water is not a very good conductor of electricity. But if I put 1 or 2 drops of acid, for example, the most common acid is sulfuric acid. If I put 1 or a few drops of sulfuric acid in water, so that is basically acidified water. So what will happen if I pass electricity through that acidified water? So what will happen, H2O will dissociate into H plus ion along with OH minus ion. So we have a plus ion and we have a minus ion. So this is basically electrolysis. So it is the process of decomposition of a chemical compound in aqueous solution or in molten state, accompanied by a chemical change. So here we are getting a chemical change. Ultimately from H2O we will be getting hydrogen gas and we will be getting oxygen gas. Okay, so there will be a chemical change by using direct electric current. So this is electricity. Now another most important point is that now most of the metals, they are very good conductors of electricity. Now how electricity flow from one point to the other? Now there are two way. One is through electrolysis. When a particular compound, we take a particular compound, that compound should be in a molten state, that compound should be in an aqueous a solution form. So we are passing electricity, and from a particular molecule we are getting ions. Now another way of passing electricity is, now we can pass electricity through metals. Those are known as metallic conductors. We have heard about this term, metallic conductors. Now if I take for example, copper is a very good conductor of electricity. Then silver is a very good conductor of electricity. Aluminium is a very good conductor of electricity. So these are basically metallic conductors. They allow electricity to pass through them, and these are basically a process that is the electrolysis, a process by which the electrolytes. Now we are coming to another term, that is electrolytes. Now the electrolytes, they allow the electricity to pass through them so that the molecules get converted into ions. Now what is basically an electrolyte? Now another new term we have come, that is electrolyte. Now what is an electrolyte? Now electrolytes are basically compounds. Now electrolytes are basically compounds, and they are always either in a molten state or in a aqueous solution. Either in molten state or in aqueous solution. Okay, and they will allow electric current to pass through them. So this electrolyte, we can pass electric current. So we can pass electric current through the electrolytes. Okay, now the electrolytes, they can be molten salts, they can be solution of salts in water, they can be a solution of acid, they can be solution of alkali, they can be alkali. What are basically alkali? Alkali are bases which are soluble in water. Okay, now let us give you some example of electrolytes. Now if I take into consideration some acids which act as electrolytes, for example H2SO4. H2SO4 is a very good electrolyte. We have HNO3. H2SO4 is sulfuric acid, HNO3 is nitric acid. Then we have H3PO4. This is phosphoric acid. HCl, this is hydrochloric acid. Now, if I write down some alkalis, which are a very good electrolyte, for example, NaOH, sodium hydroxide, KOH, potassium hydroxide, then we have NH4OH, ammonium hydroxide, then we have CaOH whole twice, calcium hydroxide. Okay, and if I write some examples of salts which acts as good electrolytes, they can be NaCl, sodium chloride, that means the normal salt that we use in our day-to-day life. Then we have copper sulfate, CuSO4, good electrolyte. We have PbBr2, it's also a good electrolyte. It's basically lead bromide. Okay, now electrolytes. Now we know electrolysis is the process and electrolyte is the compound which allow electricity to pass through them so that the molecules or the compound, it can be an acid, it can be an alkali, it can be a salt, they dissociate into ions, a positive ion along with a negative ion. Okay, now we should know a basic difference. We should know the basic difference between metallic conductors and electrolytic conductors. Now, what are the basic difference between metallic conductors and electrolytic conductors? Okay, now, so what are the basic difference between metallic conductors and electrolytic conductors? So this is basically electrolytic. Okay, we can write here metallic conductors. Here we can write electrolytic conductors. Now, metallic conductors, I told you earlier, it can be copper, it can be silver, any metal. And electrolytic conductors, they are basically any acid or any alkali or any salt, either in molten form or in aqueous solution. Okay. Now, what are the basic difference? Now, in case of conductors, now when electricity is passing through a copper wire and we are getting electricity, we can switch on our light, we can switch on the fan, the AC. So here what is happening basically, here electricity is being carried by a metal. It can be copper, it can be aluminium. So here basically in case of metallic conductors, no transport of matter, no transport of matter in case of metallic conductors. And in case of electrolytic conductors, what is happening? There is transport of matter. There is transport of matter. Now, how transport of matter? Now, say for example, H2O dissociates into H plus among OH minus. So the H plus will move towards the negative electrode. Then the OH minus will move towards the positive electrode. So we will discuss all this. So in this way, there will be a transport of matter. Okay. Now, point number two, metallic conductors. In case of a metallic conductor, no chemical change. No chemical change. Now, when electricity is passing through the copper wires in our house, so there is no chemical change. But one thing may happen, it may be heated. The copper wires, it may be heated. We can say that one. It may be heated. This one. Okay. Now, what is, this is point number one. Okay, so this is point number one. Here we have the point number two. Now, in case of our electrolytic conductors, chemical change takes place. Chemical change takes place near the electrodes. Now, we will know what are basically electrodes. Okay, so now for example H2O, we have a H plus and a OH minus. Now I can show you the my equation here itself. For example, if I write down here H2O, then I am getting a H plus and a OH minus, and then this H plus, so this will accept one electron and we will get a H, and similarly two H will combine and they will form a hydrogen gas. Okay, and we will get this hydrogen gas near any electrode, near a particular electrode. I will talk about that also. Near a particular electrode, for example, this OH minus will lose the electron, we will get OH. So similarly we can accumulate 4 OH and we can get 2 H2O. Okay, and along with O2, that means oxygen gas. So 4O, we have a 4O and we have a 4. Yeah, correct, this one. So we are getting oxygen, oxygen gas. We are getting also near the electrode. That means basically we are getting hydrogen and oxygen gas near the electrodes after the chemical change took place. So this is the second point in case of electrolytic conductors. Now we are coming to the third point. Okay, now what is the third point? Now in case of metallic conductors, now the electrons, they basically carry the electricity. So the electrons are responsible. The electrons, they carry the electricity. They basically the flow of electron. Now the flow of electron is basically responsible for electricity to flow from one point to the other. So we can put in this way. Now point number 3, in case of electrolytic conductors, what is happening? Now the electricity is carried by the ions. Here electricity is carried by the ions. So we have a H plus ion here, we have a OH minus ion here. Now these ions are responsible to carry electricity from one point to the other. That means throughout the electrolyte, and they are reaching the electrodes, and there we are getting new elements. Okay, we are getting new elements. Okay. Now what are the other points? Some more points. The differences between metallic conductors and electrolytic conductors. Now in case of a metallic conductor, point number 4. Now if I increase the temperature, so what will happen? The conduction, that means the passage of electron, that means the conduction. So the conduction, that will lower the conduction. Why? Because we are basically, by increasing the temperature, we are basically increasing the resistance. Now what is happening in case of electrolytic conductors? Now here, if I increase the temperature, so what will happen? The electrolytic conduction, that will increase. Because why? Because if I increase the temperature, there will be a increased dissociation in the ions. So there will be basically an increase in the number of ion. There will be increased ions. Why? Due to increased dissociation. So what will happen? More water molecule will be dissociated into H plus and a OH minus. Now if I move on to the another point, if I move on to fifth point, okay, now if I write down the fifth point regarding metallic conductor. Now here in this case, in case of metallic conductors, the conductors are always solid when electricity is moving from one point to the other. Whereas in case of electrolytic conductors, point number 5, now they are always either in solution form or in molten state. Okay, got it. Now we are moving on to the next concept, that is Okay, now we know what is basically electrolysis, how current is moving from one point to the other, what are the basic differences between metallic conductors and electrolytic conductors. We have discussed some examples of the electrolytes. What are basically the electrolytes that we know. Now we should know what are basically we should know what are the characteristics of electrolytes. Okay, now the next point. Now the next point is, what are the characteristics of electrolytes? Characteristics of electrolytes. Now, what are the characteristics of electrolytes? Okay. Now, what is the first characteristic? Number one. Now, electrolytes are always compounds. They are always compounds. This is number one. What is the number 2 point? Now, they dissociate into ions. They dissociate into ions, and the compounds they should be either in a molten state or in solution, basically aqueous solution, basically molten state or aqueous solution. Now, what is point number 3? Now, point number 3 is the ions of the electrolytes. Now, who are basically responsible for the passage of electricity? Now, the ions of the electrolytes, they conduct electricity. So, they conduct electricity. What is the 4th point? Now, if I increase the temperature, what will happen? There will be an increase of ionization. And that will increase the electrical conductivity. Got it? Okay. And what is the last point? The last point is, now when electricity is moving through the electrolytes, there will be a chemical change. They undergo chemical change. So these are the 5 characteristics of electrolytes. Okay. Now, what is the next point that we should learn? Now we will know something about electrolytes. What are the 2 types of electrolytes? Now, what are the 2 types of electrolytes? 2 types. One is a strong electrolyte. Another one is a weak electrolyte. Okay. Now, what are basically strong electrolyte? What are basically weak electrolyte? But before that, we should discuss a basic point that we have missed. Now, we talked about conductors. Now, conductors are basically metals or alloy, and they allow the passage of electricity from one point to the other. Now, there are some non-metals which do not allow the passage of electricity through them. Those are basically known as non-conductors. Those are basically non-conductors. And we know what are basically electrolytes. So there is another term which is known as non-electrolytes. For example, now NaCl in fused condition or molten state or in aqueous solution, that is an electrolyte. But if I take NaCl solid, that is a non-electrolyte. So that is a non-electrolyte. So we should understand all the points. Number 1, what is a conductor, what is a non-conductor. For example, wood is a non-conductor, glass is a non-conductor, then rubber is a non-conductor. Okay, so these are basically examples of non-conductor. Now we should know, we have already learned what are electrolytes. We should know what are basically non-electrolytes. Okay. Now coming back to the point, strong electrolyte and weak electrolyte. Now the strong electrolyte, they allow large amount of electricity to flow through them. So that is the first point. So the first point is what they are doing. They are allowing a large amount of electricity. So they allow large amount of electricity. So they will allow a large amount of electricity to flow through them. Now in case of a weak electrolyte, they will allow small amount of electricity. Small amount of electricity to flow through them. Okay. Now number 2 point, in case of a strong electrolyte, now they are basically good conductors. Strong electrolytes, they are basically good conductors of electricity, whereas weak electrolytes, point number 2, they are poor conductors of electricity. Now in case of a strong electrolyte, now these are almost basically they are completely dissociated. Now when the electrolytes, they are in a fused or in a aqueous solution state. Now the strong electrolytes, they are completely dissociated. Okay, got it. Dissociated. Okay. And in case of weak electrolyte, they are partially dissociated when they are in a fused or molten state or in a aqueous solution state. Okay. Now point number 4, in case of a strong electrolyte, now they only have free ions. They have free ions in case of a strong electrolyte. Now these are basically solutions, and they contain only free mobile ions. So we can say free mobile ions. And in case of a weak electrolyte, they contain ions, and they also contain molecules. Ions along with molecule. Point number 5, in case of a strong electrolyte, now if I do one thing, now if I take a chamber, now that we call as an electrolytic cell or a voltmeter. And if I put electrolyte within that particular voltmeter or electrolytic cell, and we are putting 2 electrodes, and both the electrodes are connected with both the terminal of the battery, positive and negative. And if I put within the circuit, if I put a bulb and if I put a switch, and if I switch on, so what will happen? So the electrolysis will start. So the electricity is moving, and the bulb will glow. So in case of a strong electrolyte, so the bulb will glow brightly. Whereas in case of a weak electrolyte, the bulb will glow dimly. It will glow dimly. So these are basically the difference between strong and weak electrolytes. Okay. Now again we will define some basic concepts of electrolytes before moving on to the some complex concepts in this particular chapter. Now we should know what is basically a electrolytic cell. Electrolytic cell. What is an electrolytic cell? Another name of an electrolytic cell is voltmeter. Now what is basically an electrolytic cell? It is basically a non-conducting vessel. Basically we can make a voltmeter with the help of a glass. Okay, so it is basically a non-conducting vessel, and where we are conducting the electricity, electrolysis basically, where we are basically conducting the electrolysis. So that is basically electrolytic cell. Okay. Now what is basically an electrochemical cell? Now this is electrolytic cell. Basically, we have an electrolyte within that particular cell. We put two electrodes. One is the cathode, another one is the anode. Connect with the positive and the negative terminal of the battery, and we can start the process which is known as electrolysis. And what is the electrochemical cell? Electrochemical cell is basically the battery. Chemical cell, that is basically the battery that we have to connect with the electrodes basically. Okay, so it is basically a device and it converts chemical energy into electrical energy. So here the chemical energy gets converted into electrical energy. For example, simple voltaic cell is one, Daniel cell is another. Okay, now what are basically electrodes? Now these are basic terms that we should know all. Now what are basically electrodes? Now electrodes, they are two metal plates. They can be metal plates. They are basically two metal plates, or they can be graphite rods, or we can say gas carbon rods, or we can say made up of gas carbon rods, and they are immersed. Now, so this is basically a voltmeter. Within the voltmeter, we have this is the electrolyte. Then these are the electrodes, and they are connected with the positive and the negative terminals of a battery. So it's a very simple diagram. So they are basically, now these are electrodes. This is the electrode, this is the electrode. They are basically immersed within the electrolyte, through which current enters and leaves the electrolytic cell. So that is the definition of electrode. Now there are two types of electrode. One is anode, another one is cathode. One is anode, another one is cathode. Now what is anode? Anode is connected with the positive terminal of the battery. Positive terminal. So this one is positive, this one is positive, and this one is negative. Okay. So this is basically anode is connected with the positive terminal of the battery, and cathode is connected with the negative terminal of the battery. Got it? Clear? Positive terminal and negative terminal. Okay. So got it. So anode is positive, cathode is negative. Okay. What are the basic differences between anode and cathode? Another very common question. So anode is connected with the positive terminal of the battery, cathode connected with the negative terminal of the battery. Now the anions, they migrate towards the anode, and the cations, they migrate towards the cathode. Now another concept is, anode is basically a oxidizing electrode. We will learn all these things. Oxidizing. Now let us first use the term oxidizing electrode. It is an oxidizing electrode. So basically oxidation takes place at the anode, and cathode is a reducing. It is a reducing electrode. So basically reduction takes place here at cathode. So anion is basically what? Anion is basically negative charged. So that is moving towards the positive charge anode, and cation is basically positive charge, that is moving towards the negative charge, which is cathode. Okay. Cations and anions we know. Okay. Another two things that we will learn today, and then we will complete today's session. So we should know what is basically oxidation and what is basically reduction. What is oxidation and what is reduction? Now what is oxidation and what is reduction? Now oxidation means, oxidation, we should learn this one, oxidation and reduction. So this is the last topic of today's session, oxidation. Now oxidation means, now for example, if I have a sodium, now for example, if I have a sodium atom and that particular atom is losing one electron and we are getting Na plus, which is basically a cation, this is oxidation. This is basically oxidation. So in an oxidation, it is defined as the process in which an atom or an ion, it loses electron. For example, an atom loses electron, oxidation. Now we can show ion, for example, Fe2 plus, it's an ion. Now when it's losing electron, we are getting Fe3 plus. So that's basically oxidation. Okay. Now another basic things to learn about oxidation is, number one, oxidation means addition of oxygen. Addition of oxygen. For example, carbon along with oxygen, what we are getting carbon dioxide. That is oxidation. Oxidation means removal of hydrogen. Removal of hydrogen. For example, if I write down one equation, H2S plus Cl2, we are getting 2HCl plus S. So now from H2S we are getting S. So here we have a removal of hydrogen. So that is oxidation. Addition of oxygen, oxidation, removal of hydrogen, that is oxidation. Now we should know what are basically oxidizing agents. What are oxidizing agents? Now an oxidizing agent is one which oxidizes other substance. Now they oxidizes other substance. They oxidizes other substance, okay, but they itself, they are reduced. Now how they can oxidize other substance? Either by accepting electron, or by providing oxygen, or by providing an electronegative element, or by removal of hydrogen, or by removal of an electropositive element or an ion. So in this way, so these are basically oxidizing agent. They oxidize other substance, but itself they are reduced. Now if I write down some examples of oxidizing agent. Now oxidizing agents which are solid, for example, manganese dioxide, MnO2. For example, red lead. Okay. For example, lead dioxide. These are some examples of solid oxidizing agent. Now, liquid oxidizing agent, for example, H2O2, hydrogen peroxide. For example, concentrate HNO3, nitric acid. For example, concentrate H2SO4, sulfuric acid. For example, bromine, Br2, they are liquid oxidizing agent. Now, if I write some examples of gaseous oxidizing agent, okay, they can be oxygen, they can be ozone, they can be chlorine, they can be sulfur, they can be SO2, sulfur dioxide. Okay, so these are gaseous oxidizing agent. Now, just ulta is reduction. Now, what is basically reduction? Now, reduction is basically, for example, now this is basically removal of electron. So this will be when we are accepting electron. That means atom, for example, sulfur accepts 2 electron and we are getting a S2 minus. So this is basically reduction. So reduction is basically when an atom or an ion gains electron. Here we are seeing atom gaining electron. Okay, now we can show this one also. Fe3 plus, and when it gains electron, now we are getting Fe2 plus. So that is basically reduction. Also we can say removal of oxygen. that is the reduction. Removal of oxygen, that is reduction. Now we can write down one example. CuO plus H2, that is Cu plus H2O. So removal of oxygen, so from CuO to Cu. So this is removal of oxygen, so this is reduction. Then addition of hydrogen. Addition of hydrogen is also reduction. For example, if I write down this equation, Cl2, now the same equation if I write, now this is Cl2 plus H2S, what we are getting, S plus twice HCl. Now here from Cl2 to twice HCl, this is addition of hydrogen, so this is reduction. And what are basically reducing agents? So what are basically reducing agents? Reducing agent is one that reduces other substance. What they do? They reduces other substance, but itself they are oxidized. ठीक है ना? So they reduces other substances. Okay. Now examples. For example, if it is a solid, then examples are carbon. Now we can write down some metals. For example, zinc, aluminium, then copper, then sodium, then stannous chloride. For example, glucose. These are all solids. Now if I write down some examples of liquid which are reducing agent, for example, hydrogen peroxide, then hydrogen iodide HI, then we have hydrogen bromide HBr. So these are basically liquid. Now some examples reducing agents which are gas. For example, hydrogen sulfide H2S. For example, carbon monoxide CO. For example, sulfur dioxide SO2. So I think this much for today. So next day we will again proceed with electrolysis. Okay.